my name is Charlie. I'm an engineer working with our go-to-market team at MemVerge. So this presentation is going to be covering a lot of what John has already talked about, but also going over some of the use cases and diving deeper into our actual architecture. Yeah, so starting off, why MemMachine? Or I guess I should start off with explaining what is MemMachine. So MemMachine essentially provides the memory layer for AI agents, and we really saw the need for this back a couple, I want to say last summer when we first started delving into the realm of AI agents, right? Me included, I think a lot of people thought that you could just build a chatbot with a simple RAG and that would work, right? So something that we tested out originally was just building a chatbot connected to some of our Confluence docs that were vectorized. But then we started seeing an issue with, hey, it's still kind of stateless, right? I can send in one interaction in a chatbot that's hooked up with like a Quen model or OpenAI model. I could say, my name is Charlie, and the next interaction, if I asked what my name is, it wouldn't know. And a lot of the same issues with RAG that we heard from the previous speaker. So that's kind of where we started off, and then we found the need for actual agentic memory, right? 2025 was a big year for agents, and we think that'll only keep growing. So MemMachine provides a memory solution for that. And we do this in kind of two parts that I'll go over later. But the big things are we have a semantic memory. Semantic memory is kind of a persona for the user, right? Not every actual agent will need this, but we find that a lot of agents will actually benefit from learning more about the actual user. So things like, what are the user's interests? Do they like verbose responses? Do they want data in bullet points? Stuff like that. Then we have our episodic memory. Episodic memory is composed of both short-term memory, but also long-term memory. So short-term memory works within the living session, right? If you can imagine ChatGPT, you can have multiple tabs open within that. That's our short-term memory. Per tab would have its own memory. Then we have long-term memory. Long-term memory is kind of the bulk of MemMachine, right? It remembers everything about the user's interactions, storing all the raw logs. Yeah. Looks like some of the slides aren't here. So I'll just go over, since the slides aren't seeming to show up, some of the use cases we've seen so far. Originally there were three testimonials here, but just go over them by word. So some of our existing use cases we've seen, one is actually a pretty creative thing, right? So we know this person called Jenny O Yang. She's a big Substack influencer, but her big use case for MemMachine is she wanted to create basically an ability to find other Substack creators within the same domain, right? So she writes about a lot of tech. So she has been a big user of our semantic memory. So she'll ingest her own personal articles and whatnot, and then basically look for other people with similar aspects to that. Then another one is Teammate. Teammate is a startup founded with the idea of integrating different enterprise tools, right? So if you can imagine Outlook, Calendar, Zoom transcripts, Slack, all working together and having its own AI. They use our episodic memory. So within a Slack channel, you can have different people talking in it. They'll all have an instance of that memory. And how we actually partition that memory goes into our API design, right? So we have a lot of thoughts around privacy, but the big thing about privacy to us is that if you're in the room, then you should have that memory. So similarly, if you're in that Slack channel, if you're in that Zoom meeting, if you're one of the editors in a Google Doc, then you'll have that memory. Another testimonial we had was from a group called Caregiver. I think Frank mentioned them previously. They were a former hackathon winner of ours that ended up taking their idea and trying to turn it into a full product. But their idea is they want to be able to help dementia patients, and specifically the caregiver of dementia patients. So I'm not sure how familiar you guys are with the health space, but for a lot of families of people with dementia, a big thing they have to know is kind of the daily trends throughout the weeks, the months, the years of how the patient progresses. So for example, if someone's dad has dementia, then their kid is taking care of them, they want to be able to know all the things that that person did, if they did good today, if they remember certain things. And that information is really useful to a doctor to be able to see how much they've really progressed. Because from a doctor's point of view, every single visit they have with their patient, they only kind of see that one day, right? And then whatever that their caregiver actually remembers. But if they had an application to be able to connect all these things and be able to take notes throughout these days, months, years, then the doctor has a more full picture. And their use of MemMachine is pretty self-explanatory. MemMachine provides the memory aspect for that. Now, going into this is our actual architecture. So at the top level, we have our API. You can integrate it with our Python SDK, just a simple pip install, our REST API, or MCP. In terms of our REST API, you can self-deploy it just within Docker or on-prem in your VPC, but also we're soon to roll out our hosted REST API platform. So this will allow you to be able to go into our website, create an API key, and then just use our REST API. Our MCP server, I want to highlight because I think in one of the previous talks, we talked about being able to integrate different tools that people are already using, right? For a lot of engineers that I know, they like to be able to integrate with both Claude and Cursor, right? Cursor for actually writing the code, but maybe they want to brainstorm in Claude, or maybe they have other ideas in ChatGPT. You can connect our MCP server to any AI tool that can integrate with MCP and allow all those different tools to be able to access that same memory. Now, going under, we see MemMachine broken down into semantic memory and episodic memory. And at the lower level, we have our databases. So I want to talk more about our profile memory. By default, our profile memory remembers things like your interests, hobbies, stuff like that. But you can also adjust the behavior of this, right? So we've had people we've talked to in the past that have used our profile memory for different purposes. Taking Jenny Yang, for example, she used profile memory in order to basically get information about writing style, topics, stuff like that. In the same tone, you can change profile memory's behavior to remember things like CRM, right? If I wanted to build something into, like, say I wanted a Slack channel dedicated to CRM, I could then adjust the behavior of our semantic memory to remember aspects about customer deals. How much did this sell for? How long have we been talking to them? That all runs within a PostgreSQL database, but you can also adjust it to use AWS's, I think it's RDS or Aurora, if you work within the AWS ecosystem. Then we have our episodic memory. Episodic memory, as I mentioned before, is kind of the bulk of MemMachine, right? It has both short-term memory and long-term memory. The short-term memory, as I mentioned before, is session-based. That runs in a SQLite database. So basically, you can input messages. It's almost like a queue, right? First in, first out. Then we have our long-term memory. This runs on a Neo4j graph database. So within the workflows that we typically see, taking, I guess for simplicity, a chatbot, every single message would go into our long-term memory. And then when you search it, when you ingest it, actually, we break it into different nodes, right? We use a sentence transformer to first break down the actual sentence, and then we vectorize it. When you actually search it, one of the important metadata fields that we use is timestamp, right? So taking human memory, for example, if I remember something that's important from last week, then probably like the hour before or hour after is probably relevant as well. So we try to use that as a model for us. When you search something, if we find a vector that's highly relevant, then we also search the timestamps around it. Getting all those nodes at the end, we then pass it to a re-ranker model to provide the most accurate responses for the user. Yeah, so this is our REST API. I know it's a lot, but I want to highlight just a couple of them. So at the top level, we have project ID and org ID. And you might be wondering, why do I need this, right? Project ID is essentially defining the actual space you're going to work in, right? So We've had people build MemMachine into different Slack channels. For them, a project ID might be the channel name, right? Producer is the actual user who produced this. So this could be maybe the agent. So I could say ChatGPT is the producer of this, or the producer can be the user. So for example, Charlie is the producer. Produced for is the intended reader of the message. So this could be in a Slack channel, all the people in the Slack channel, or this could be the agent. Then we have type. Type is, by default, if you pass nothing, it'll ingest into both semantic and episodic memory. Vice versa, you could also specify an actual type if you only want to use one aspect of MemMachine. Then we have role. Role, pretty self-explanatory. But the big idea with this is we want to allow the user to basically partition their data, right? Going back to the example of Teammate, right? They have a lot of different tools that they might integrate with, but they want to be able to partition memory based on, first, what tool it's being used at, and two, who has access to the memory.